Okay, so now let's talk about the interesting ones. So we're going to talk about the H1N1 from 2009, the swine flu, and the bird flu, H5n1. So the difference here is that H1N1 has a fatality rate of something like 0.01%, so very low. Um, and the H5N1 has fatality rates from about 50% to 100%. So it's real bad. These are both influenza A viruses. They have a different combination of hemagglutinin and neuraminidase. They have the same N1 but a different H type, different hemagglutinin type. So let's get into this. Let's see what the difference is. Why does one really kill birds? Because bird flu just tears through birds. It kills them as badly or worse than humans, but doesn't grow well in humans. And H1N1 spreads fantastically well among humans, and birds really can't get it. So let's see. Okay, on 21st of April 2009, the first case of pandemic H1N1 2009 was reported by the CDC in California. We don't know when exactly the virus would have erupted, but it would have been sometime around then, we think, or maybe just a couple months earlier. So either late '08 or early '09, but probably sometime early '09. Case fatality rate was 0.2% initially, ugh, but later we figured out that the virus was not particularly deadly, and it only really badly affects people who have a second kind of bacterial infection in their lungs at the same time that they have the H1N1. So people with this bacterial infection, which is what is it? Streptococcus pneumoniae. Yeah, I believe that's the correct one. Um, would have a 10,000 times greater risk of dying from H1N1 than people who just had H1N1 alone. So yeah, but we did not know that at first. We figured that out over time. And this was an H1N1 and what caused the pandemic. So let's have a look at it. All right, so how does this one compare to previous H1N1 viruses? So there's the 1918 flu, and so we know that thing existed, and we can kind of put together what this was. And then after 1919, once we get to 1920, people still get the flu, but it doesn't seem to be killing them as much. It seems to have mellowed out. And so, because it's so long ago, we don't really know whether the virus shifted to perhaps a different hemagglutinin or one of the different segments, or whether it was just a case of that it killed off everybody that it could. And yeah, now the survivors were kind of resistant, so hard to tell. Anyway, that flu goes on and it dies out in the 1950s. And then it reemerges in the 1970s as the Russian flu. And but meanwhile, all this time, we've had the classical swine flu going on in pigs. And so the human virus never completely disappeared. It stopped growing in humans for a couple years. It was replaced by that H2N2, but it was still growing in pigs because pigs have a very similar sort of way that they have sialic acid on their proteins to what we have. So they're quite similar. And so, yeah, the classical swine flu was really just leftover 1918 flu, but in pigs. And so then it jumps back over into humans in the 1970s. And from there, the story gets interesting. So, the 1918 Spanish flu has about a 90% similarity to the H1N1 swine flu, Mexico '09. So it's basically picked up the hemagglutinin and neuraminidase the hemagglutinin, the H1 gene of the old Spanish flu. It's back. Yeah, then this is what was circulating in pigs. Now, between pigs and humans, we have this antigenic drift. So it was 90% identical to old 1918. That's what pigs were keeping around. But one of those strains had mutated just enough that it's now only 79% identical to the old 1918 flu. And that was the one that antigenic shifted and sort of recombined with all the other segments that made up the H1N1 pandemic influenza from 2009. Okay. And a neat thing, the reason why we know this is right, it turns out that there are a bunch of people who were 80 years or older in particular, and some people who were in the sort of 65 years and older group. So those are the pink dots you can see over here and the green dots. And you see how they have higher, uh, the points go higher, the geometric mean titer is a little higher. What that means is that these people already had antibodies to the swine flu before it had come back into humans as the swine H5n1 in 2009 because they had already experienced this virus back in the day. So they had already caught viruses descended from the 1918 virus that circulated till 1957, or they had caught the Russian flu. But it seems like only the ones that had caught the original virus before it came back in the 70s were actually immune, had a nice long lasting immunity. So, yeah, that was kind of nice. Old people were kind of protected from this one. And so there we go. The really high bars there are in over 80-year-olds who are not normally associated with and known for their really functional and good immune responses. But there you go, absolutely off the charts. So they had these strong responses because they were kids when the original 1918 flu would have come around, and so they were able to, yeah, they had already seen this virus. And there's a neat thing with flu viruses. It's called original antigenic sin. So original sin, you know about, like somebody does a sin and then bam, all of humanity pays for it forever. Original antigenic sin, the idea is that the first flu virus you get, you will make a long lasting, lifelong, in fact, and really strong immune response to that. But every flu virus you get after the first one, you'll make a kind of a weak immune response that'll last for maybe a year and then go away. So the first flu virus that you got, you're probably going to be immune to that for life. But every other flu virus that you get after that, yeah, no immunity. So as long as the flu virus itself doesn't change that much, you're going to be well set up for the future. But so the question is, like, you take an older person like me. So I was around when the original H5n1 was still around and H3n2. So the question is, which one did I catch at that time? Because I didn't seem to get much flu, at least up through 2008. But then I started getting the flu again in 2009. So it may have been that I had the old H5n1, made a really great response against it, and then just have nothing, nothing now when it comes to the new one. So, yeah, that's how it works. Okay, so it was, yeah, an absolute jackpot. When the segments came together and made this swine origin H5n1 influenza in 2009. Because as people who make vaccines have learned, you can't just get any 8 segments together. They won't always work together, they won't always make a working virus. You got to get lucky. And it just so happens that this virus was one of those lucky winners that recombined bits of 3 different strains to make one brand new virus. Okay, so that is the H5n1 swine flu, and now let's contrast that with the H5n1 avian flu. Okay, so H5n1 is widespread in poultry, but when it happens, you know it's happened because all of your chickens will drop over dead really quickly, one after another. And this thing can then spread to humans. And so you see them down there with their little N95 respirator masks. That's a good idea because otherwise, yeah, they might catch avian flu. And avian flu is bad. So, 1997, we had the first recorded human cases. We had 18 cases, 6 dead. So, yeah, 1 out of 3. And then it reemerged several times since 2003 because the birds always have some version of this. Remember, H5n1 never goes away, and things like ducks carry it forever. It's just when it gets into chickens, it kills all of them, and when it gets into us, it does bad things to us. So people in particular who were around chickens um, or ducks, for example, would have really would be where you'd find the cases, and these people had a greater than 50% mortality rate, sometimes up in the 90% range for particular outbreaks. There was one family I remember in Vietnam, and they had a bunch of ducks that lived in the house because that's basically what you do. And so the ducks are in there, they're running around on the floor, and these people lived with ducks. It turns out the ducks had H5n1, but they would also eat raw duck meat, and they would prepare the ducks in the house because, where else are you going to prepare it, right? And they were also drinking raw, uncooked duck blood, which is, it's the good way to get it. And so this was one case where we had an entire family come down with H5n1. I believe there were several deaths there. But that is very much not the norm. Usually H5n1 will hit one person or one or two people and then die out. It doesn't seem to spread well from one person to another. So, why is that? Well, we'll get to that, but they're basically looking for different receptors, different types of sialic acid. Okay, so yeah, quite recently, yeah, two different groups managed to mutate H5n1, the avian flu that kills everybody, birds and people alike, so that it transmits relatively easily in the lab. So the Yoshi Kawaoka and Ron Fouchier at Erasmus over in the Netherlands, these guys, yeah, both independently did this experiment because ferrets are considered a really good model. Ferrets have just the right sialic acid, and you can grow bird flu in them, and you can grow regular people flu in them. So it's nice. You got one animal where you can compare the effects of different flu viruses, for example. And what they found was that once they'd put the virus into ferrets and got the virus back out, now it would spread readily to other ferrets, and it turns out it would spread to other animals as well. Yeah. So they're the closest thing to human influenza infection that's not a human, but they are adorable. Yeah, look at them. Oh. But similar symptoms, similar severity. That's all right. So the U.S. government and actually the government of the U.K. did block the publication of some of this data, and it was on sort of anti-terrorism safety grounds. The idea was if you publish this thing that says you can turn an ordinary bird flu into a potential human killing pandemic flu just by passing it through ferrets first. And they thought if this information gets out, then, what would Osama bin Laden do? Yeah, I guess they were wearing those bracelets instead. um, and so there were concerns, definite concerns. So, yeah, the chair of the U.S. National Science Advisory Board for Biosecurity said that I can't think of another pathogenic organism as scary as this one. I don't think anthrax is as scary at all compared to this. But on the other side, you got the editor of the journal Science, which is the big boy scientific journal where you all hope to publish someday. And he's on the other side. He says, well, we got concerns about withholding information that is of public health importance, and says that many scientists in the influenza community would have a bona fide right and need to know the details of this research in order to protect both themselves and the public, especially if they are currently working with related strains of the virus. So, like I said, ferrets are a common model, and just that most people are growing regular flu in them, not avian flu. But if growing your avian flu virus in ferrets is going to mean that the investigators are potentially at risk and at risk of spreading this virus, then yeah, that's a good thing. You want to make sure everybody knows, right? So they were trying to balance out these ideas, like what's the right way to handle this. And the consensus that's come down now is that generally we're going to share with the WHO first and share with the governments of probably at least all the G8 countries. And they're going to get a look at it so that they can get out ahead of the problem. And if it's something really easy, like how to build a nuclear bomb in your backyard, then probably they're going to say, don't publish that. The public doesn't have a good reason to know. But if it's something like if you do this in a lab, this is how a virus can get worse or something like that, then they would say, yeah, public does have a right to know, but we want to make sure that we can do everything in our power to protect them. And so that's the interesting ethical side of working with flu viruses. Yeah, you potentially put the entire world at risk, but you have to do that in order to understand what's going on. Okay, and last one. What characteristics do flu viruses require to replicate and transmit efficiently in the human population? So this is the teaser for the next lecture. I think there's two more little sections of this lecture, and then we are done. So I'll see you in that one. Bye bye.